Hey guys, the next topic for this section is special angles and reference angles. Now, one of the things we've already looked at is the angles from the 30-60-90 triangle and the 45-45-90. And those come up often enough that you should memorize them. So we've really already seen the middle part of this table here. I've thrown the tangent values on there as well. You can find the tangent values if you remember that tangent is sine over cosine. But let's look at 0 and 90, because when we're dealing with triangles, with right triangles, we didn't talk about sine of 0 and sine of 90, because we only talked about the sines of the other two angles. And in a right triangle, those angles are always strictly between 0 and 90. But if we use the definition with the unit circle, we can come up with the values for sine and cosine and tangent of 0 degrees. First up, let's look at 0. If we look at 0 degrees, that's going to be this point here. And if you look at this, the coordinates of this point are x-coordinate is 1, y-coordinate is 0. And remember, the points on the unit circle, x is cosine theta, y is sine theta. So for this point, for 0, this tells us that cosine of 0 is 1, and sine of 0 is 0. Now if we come up here, this is at 90 degrees, and the coordinates of this point are 0, 1. So remember, this first value is the x value, that's the cosine of 90, which is 0, and then the sine of 90 is going to be 1. Now, we could go and look at the other angles as well. We could use this to get the sine and cosine of 180 degrees or 270 degrees. These are called quadrantal angles. Quadrantal because they lie on the axes, the boundaries between the quadrants. But this is you should memorize this chart. And let me mention a couple of things about it. Notice for sine, if you look at it, the values going from left to right, this is 0, and then it's the square root of 1 over 2, square root of 2 over 2, the square root of 3 over 2, and the last one is the square root of 4 over 2. Of course, that one reduces down to 2 over 2, which is 1. And here I call this the square root of 1 over 2, but that's also just 1 over 2. So you can memorize it like that, 1, 2, 3, 4. So that's the sines. The cosines are the exact same numbers, but they're in reverse order. 0, half, root 2 over 2, root 3 over 2, and 1. And then I mentioned above, tangent is sine over cosine. So you can get these tangent values by just doing sine over cosine. So in this case, it's 0 over 1 is 0. Half over this, when you do some reducing and stuff, you get root 3 over 3. This divided by this gives you 1. This divided by this gives you root 3. And 1 divided by 0 is undefined. So anyway, these come up often enough, it's really advantageous to memorize this entire chart. Okay, I want to do a couple of examples here. This is going to lead up to the idea of reference angles. Draw the point on the unit circle at theta equals 150 degrees and use it to determine sine of 150 and cosine of 150. Let's do that and then verify on a calculator that it's correct. All right, so unit circle. All right, this is 180 degrees. So 150 degrees is going to be back here. So how am I supposed to do this when I don't have those values up here? Well, notice this. I'm going to come over here and in purple, I'm going to draw in this. Now my circle is not great, but these 2 points, they have the same height. The x coordinate or the y coordinates are equal, and the x coordinates, if we look at how far over they are, their x coordinates are the same number, but one's positive and one's negative. So let's look at this angle right here. This little angle inside of here is, let's see, that's 150 degrees, this is 180, so this is 30. 30 degrees in between. If you come over here and look at this, this is also 30 degrees. And so what we know up here is this is going to be, remember it's cosine theta so this point, the cosine of 30 degrees is root 3 over 2, and the sine of 30 is 1/2. And if we think about it, that makes good sense. Root 3 over 2 is like 0.866. That's bigger than 1/2. So it makes sense that it's further over than it is up. So if we look at this other point over here for 150, I'm going to slide this entire drawing over. So for 150, this point, its coordinates, it's got the same y coordinate as the purple point, but its x coordinate is going to be minus root 3 over 2. So this lets us look in here and say this is cosine of 150 and this is sine of 150. Now let's check that with calculator. 150. If I put in 150 and take the sine, I get 1/2. If I put in 150 and take the cosine, I get 0.866, which is root 3 over 2, and it is negative. So yeah, we're able to do that by using some symmetry there and using what we know from our list of special angles. All right, let's do one more of these. Actually, I want to change this problem. Instead of 270, let's make this 225. All right, so use a point on the unit circle at 225 to come up with sine and cosine of 225. Let's see, I've got this annoying line here. I'm going to use that for my axis. So here's my axis. Here's my unit circle. Get it on there roughly. My axis is not straight, but that's okay. 225, that's going to be halfway between 180 and 270. So I'm going to draw this in 225 in purple. All right. Now notice, what is this angular distance here? Well, from 180 to 225, this angular distance is 45 degrees. So I'm going to draw in a 45-degree angle up here. All right, and so for a 45-degree angle, but we know that this is going to be root 2 over 2 for both of these from the chart of special angles. And we know, of course, this is cosine 45 degrees, and this is sine 45 degrees. Okay, if you look at this by symmetry, this point down here in purple, I'm going to come over here and write it because I have room. This point in purple, its coordinates are minus root 2 over 2 and minus root 2 over 2. So if you use the, well, if we write this then, cosine of 225, sine 225, That gives us that cosine of 225 is minus root 2 over 2. And sine of 225 is also minus root 2 over 2. So if I put that in my calculator to check it, let's see, 225. Now, root 2 over 2 is 0.7071, blah, blah, blah. That's what it should give me when I take the sine of 225. But it should be negative. Sure enough, it is. Now, if I do the cosine of 225, it's going to give me the same thing. Excuse me. All right. So we did that by just kind of playing around with the symmetry and stuff. This angle that we're looking at here, this 45 degrees that we came up with here, and on the previous problem we came up with this 30-degree angle here. That's what's called the reference angle of the original angle. And that's what we're going to look at in the next video. Reference angles can help us find the values of other angles, the trig values of other angles. So we'll pick up there in the next video.